The other type of model that exists when we use dummy variables is called ANCOVA models, or analysis of covariance model. And this is a regression model that contains a mixture of quantitative and qualitative variables. So instead of having just dummy variables, we'll have some extra variables. And let's go back to our previous example, and let's suppose we add an additional quantitative variable, which is expenditure on public schools by local authorities, denoted by xi, to our previous example. So in addition to two dummy variables, now we'll have one quantitative variable, which is the expenditure on public schools. And now let's have a look at the new model. So y as before, this is the salary of public school teachers. Dummy 2, this is the dummy variable that takes the value of 1 for teachers in the northeast or north central. D3, this is the dummy variable that takes the value of 1 for teachers in the south and 0 otherwise. And xi, the new quantitative variable, this is the spending on public school per student. Let's see, now let's have a look at the estimation results, whether they are changed after we have introduced one quantitative variable. So as you can see, the estimates are a bit different, right? Now the mean value of the salary in the West is just 28,000. And if you look at the dummy variable coefficients, you will see that now both of them come with a negative sign, indicating that the teachers in the North earn less than teachers in the West, and teachers in the South earn even more or less than teachers in the West. There is the coefficient on spending per student is positive, is equal to 2.34. So if x increases by $1, the salary of a teacher increases by $2.34. As you can see, there are no p-values reported any longer. However, we've got the stars here, which indicates whether p-value is less than 5% or greater than 5%. So 1 star stands for p-value less than 5%, and 2 stars stand for the p-value greater than 5%. So first of all, let's calculate the mean salaries of the teachers. So when it comes to the West, it is equal to the intercept, and it is equal to 28,694. If we would like to find the mean salary of the teachers in the North, so we take the mean salary in the West and we subtract, in this case, the coefficient on dummy 2, and we get that the mean salary in the North is just 25,741. If you would like to get the mean salary in the South, once again, we take the mean salary in the West, which is the intercept, and we subtract, in this case, the coefficient on dummy 3. So we get that the mean salary in the South is equal to 25,583. So from this example, you can see that now teachers in the West, they earn more than teachers in the North and the South, and teachers in the South earn the least in comparison to the West and to the North. But as before, those are just statistical differences, and we would like to know whether those differences are statistically significant. And to answer that question, we need to either have a look at the t-statistic or the p-value. Luckily, we've got some information on the statistical significance in terms of p-values. So as you can see, the coefficients on D2 and D3, they come with 2 stars, which indicate that the p-values are higher than 5%. And in this case, they indicate that those coefficients are not statistically significant. So in other words, the differences in salaries are not statistically significant, meaning that the salaries in the West, in the North, and in the South are statistically the same. However, if we look at the coefficient at x, we will see that it comes with 1 star, indicating that p-value is lower than 5%, meaning that this coefficient is statistically significant. So it is different from 0, which means that there is a statistically significant relationship between mean salary and mean spending on a student. So given the results, given the statistical insignificance of the coefficient on D2 and D3, we can conclude that even though we have added x variable, so the quantitative variables, the results have not changed, and actually those results confirm our findings that the mean salaries are statistically the same in the three regions. Another interesting fact when it comes to this type of models is that actually what we have here is three models for each region, for the south, for the north, and for the west. So on this graph, you can see y has been regressed against x. So the dependent variable has been regressed against the independent variable. The intercepts, those are just the mean salaries that we've got here, right? The mean salary in the west, in the north, and in the south. So those are just three intercepts. And as you can see, the lines here are parallel. And the reason for that is that in three regressions, the independent variable is the same. It is x, and the coefficient, the slope coefficient is the same. It's 2.34. So in the three cases, the slopes are the same and they're equal to 2.34. So in this model, the intercepts are different and they're equal to the mean salaries, and the slopes are the same because we've got the same independent variable x, which enters the regression with the coefficient of 2.34. And this is how we construct this type of graphs.